Hello everyone, my name is Seyfun, and now we are going to experiment with a more intricate sound, a chord that combines three distinct tones. This will give us an opportunity to see how complex sounds differ from single pure tones when visualized in both the time and frequency domains. And now we are going to save our existing project. To keep the earlier one intact, and we will disconnect the existing signal source from its outputs, and we will copy the signal source block twice so that you have three signal blocks. And we will set the frequencies, the first one to 523.25 hertz. Apply, okay. And the second one to 1318.5 hertz. And the third one to 1568, and that's it. To combine the three tones, we will use an add block to sum their signals into one. This will allow us to hear a richer sound and observe the combined waveform in both the time and frequency domains. I will drag and drop add block from the library into our workspace, and be careful not to select this add const. No, by mistake we will add block. Here, and we will open the add blocks properties, and here you can see the num inputs. We will change it from 2 to 1 to match the three signal sources, and the type, input output type, will be set to float. Click OK, and that's it. And now we will connect the output of each signal source block to an input of the add block. And here we will connect the output of the add block to the audio sync for audio output, the QT-GUI time sync for visualizing the combined signal in the time domain, and the frequency sync for visualizing the combined signal in the frequency domain. When finished, your flow graph should look like this. Before executing the flow graph, I missed something here. So this frequency should be 1600. And here we are. And now let's run the flow graph. Also increase the sound. So the sound here is richer as it combines three distinct frequencies. This sound corresponds to a C major chord, though some of the notes are separated by octaves to make them more distinct. And a more intricate waveform will be visible, representing the sum of three sine waves. And the frequency plot will display three distinct spikes at 523.25 Hz, 1318 Hz, and 1568 or 1600 Hz. So after executing this flow graph, the frequency sync displays the frequency domain representation of combined signal. So this plot provides insights into the signal composition. Move your mouse pointer over each peak in the frequency domain plot. Observe this x-axis which is frequency value, which approximates at the frequency of each peak. And the y-axis value displayed corresponds to magnitude of the signal in decibels. Decibels measure the relative strength of the signal at each frequency. So here in this lecture, we learned how to create individual frequencies in a merged signal without the tools like FFT. The original signal frequencies of combined signal will be indistinguishable. And the GUI frequency sync here reveals these frequencies, enabling precise analysis. While we haven't discussed the decibels in detail yet, they are crucial for understanding signal strength and dynamics in both audio and radio domains. So my name is Stefan. That's the end of this section, and I'm meeting you in next lecture.